Hello, everyone. Welcome back to Research This, your go-to guide for researching anything and everything on the internet. By all means, like, share, and subscribe to the content if you do indeed find it engaging or informative in any way, shape, or form. I'm going to dive into part two of AI Research Stream. Also, in the future, I am going to be adding on upon the research. Obviously, there's a Wikipedia article. There are better sources online, so I'm going to use Google Scholar in the future. But as for this video, it's going to be more Wikipedia, but it'll give us a better understanding, a more brushstroke understanding, commonsensical kind of understanding of what we're dealing with and why. So it should be good. So simple exhaustive searches are rarely sufficient for most real-world problems. The search space, the number of places to search, quickly grows to astronomical numbers. The result is a search that is too slow or never completes. Heuristics or rules of thumb can help to prioritize choices that are more likely to reach a goal. The adversarial search is used for game-playing programs such as chess or Go. It searches through a tree of possible moves and counter moves looking for a winning position. The local search. Local search uses mathematical optimization to find a solution to a problem. It begins with some form of guess and then refines it incrementally. There's also gradient descent. It's a type of local search that optimizes a set of numerical parameters by incrementally adjusting them to minimize a loss function. The variants of gradient descent are more commonly used to train neural networks. Another type of local search is evolutionary computation, which aims to iteratively improve a set of candidate solutions by mutating and recombining them, selecting only the fittest to survive at each generation. So, as we can see, there's a form of Darwinism which is used in AI, which is fascinating to see. Survival of the fittest. What do you guys think in the comments below? Let me know. What do you think? Do you think this is a good idea, survival of the fittest, to make sure that it just constantly and continually grows and gets better and better and better and better? Is there problems to that? Do you see some sort of issue with that? I'm not sure, but it'd be fascinating to see where the future takes us for sure. Distributed search processes can coordinate via swarm intelligence algorithms. Two popular swarm algorithms used in search are particle swarm optimization, which is inspired by bird flocking, and ant colony optimization, which is inspired by ant trails. So logic. Obviously, as we're going along, we are ticking off the boxes of what forms an intelligent system that is near human-like or above human comprehension in terms of its level and capacity to simulate intelligence. That's why we're calling it artificial intelligence. So it's fascinating to see this, and we're going to dive into it. So formal logic is used for reasoning and knowledge representation. Formal logic comes in two main forms. Propositional logic, which operates on the statements that are true or false and uses logical connectives such as and, or, not, and implies. And predicate logic, which also operates on objects, predicates, relations, and uses quantifiers such as every x or y, and there are some x's that are y's. There is also deductive reasoning. Deductive reasoning in logic is the process of proving a new statement or conclusion from other statements that are given and assumed to be true, which is the premises. Proofs can be structured as proof trees, in which nodes are labeled by sentences and children nodes are connected to parent nodes by inference rules. Given a problem and a set of premises, problem solving reduces to searching for a proof tree whose root node is labeled by a solution of the problem and whose leaf nodes are labeled by the premises or axioms. In the case of horn clauses, problem-solving search can be performed by reasoning forwards from the premises or backwards from the problem. In the more general case of the clausal form of first-order logic, resolution is a single axiom-free rule of inference in which a problem is solved by proving a contradiction from the premises that include the negation of the problem to be solved. Inference in both Horn cause logic and first-order logic is undecidable, therefore intractable. However, backward reasoning with Horn clauses, which underpins computation in the form of logic programming language Prolog, is Turing complete. And obviously, Turing complete means that it absolutely passes the Turing test, which is good. The Turing test is by obviously the historical landmark of Mr. Alan Turing. I think I got that right. Comment below if I got that incorrect. Moreover, is sufficiency is competitive with the computation in other symbolic programming languages. Fuzzy logic assigns a degree of truth between 0 and 1. It can therefore handle propositions that are vaguely and partially true. Non-monotic logics, including logic programming with negationist failure, are designed to handle default reasoning. Other specialized versions of logic have been developed to describe many complex domains. There's also probabilistic methods for uncertain reasoning. Many problems in AI, including reasoning, planning, learning, perception, and robotics, require the agent to operate with an incomplete or uncertain information. AI researchers have devised a number of tools to solve these problems by using methods from probability theory and economics. Precise mathematical tools have been developed that analyze how an agent can make choices and plan using decision theory, decision analysis, information value theory. These tools include models such as Markov decision processes, dynamic decision networks, game theory, and mechanism design. Bayesian networks are a tool that can be used for reasoning. Using the Bayesian inference algorithm, learning using expectation maximization algorithm, planning using decision networks, and perception using dynamic Bayesian networks. Probabilistic algorithms can also be used for filtering, prediction, smoothing, and finding explanation for streams of data, helping perception systems to analyze processes that occur over time. Hidden Markov models or Kalman filters, which are the examples there. So, classifiers and statistical learning methods. The simplest AI applications can be divided into two types: classifiers, if shiny, then diamond, on one hand, and then controllers, if diamond, then pick up. So, obviously, these are if statements, which is like anyone that's done any form of computer science degree knows that these are key in programming. So it's fascinating to see that it's just like embedded into it. So obviously, people that study AI are very literate in computers, very hands-on. They know exactly what they're talking about. I'm not 100% an expert. I'm just the layman, kind of discovering it as I go. So it's just fascinating to me. I've kind of very passionate about it, but it is interesting to see that I do use those examples. On the other hand, classifiers are functions that use pattern matching to determine the closest match. They can be fine-tuned based on chosen examples using supervised learning. Each pattern, also called an observation, is labeled with certain predefined class. All observations combined with their class label are known as a data set. When a new observation is received, that observation is classified based on previous experience. There are many kinds of classifiers in use. The decision tree is the simplest and most widely used symbolic machine learning algorithm. K-nearest neighbor algorithm was the most widely used analogical AI until the mid-1990s, and kernel methods such as support vector machine displaced K-nearest neighbor in the 1990s. The naive Bayes classifier is reportedly the most widely used learner at Google, due in part to its scalability. Neural networks are also used as classifiers. So, artificial neural networks. An artificial neural network is based on a collection of nodes, also known as artificial neurons, which loosely model the neurons in the biological brain. It is trained to recognize patterns. Once trained, it can recognize those patterns in fresh data. There is an input, at least one hidden layer of nodes, and output. Each node applies a function, and once weight crosses its specified threshold, the data is transmitted to the next layer. A network is typically called a deep neural network if has at least two hidden layers. So it's hidden layers. I feel like Shrek talking to Donkey right now. We're ogre, we got many layers. We're peeling off the layers of AI. We're getting down the rabbit hole. So learning algorithms for neural networks use local search to choose the weights that will get the right output for each input during training. Most common training technique is the back propagation algorithm. Neural networks learn to model complex relationships between inputs and outputs and find patterns in the data. In theory, a neural network can learn any function. In feed-forward neural networks, the signal passes in only one direction. Recurrent neural networks feed the output signal back into input, which allows short-term memories of previous input and events. Long short-term memory is the most successful network architecture for recurrent networks. Perceptrons use only a single layer of neurons, deep learning, and they use multiple layers. Convolutional neural networks strengthen the connection between neurons that are close to each other. This is especially important in image processing, where a local set of neurons must identify an edge before the network can identify an object. there's also deep learning. So we're getting down here and it's getting really close to see how intricate it is, how deep the level of understanding you need for all other forms of computing is necessary in order to actually compete on this level, because there is going to be a huge transference of wealth. I just personally believe this. People can leave their comments in the comment section below. Do you believe there's going to be a massive transference of wealth? Will the world's next billionaire be member of the AI class, so to speak? Will that form into this kind of dystopian future where we've got the richest people in the world owning all the patents to every AI technology known to man, and therefore everyone else that comes after them has to kind of pay the fee, pay the piper, so to speak, to engage, and this can involve a barrier to entry for anyone that wants to get in on the AI market. So it'll be interesting to see where everything goes. Deep learning. So deep learning uses several layers of neurons between the neural network's inputs and outputs. The multiple layers can progressively extract higher level features from the raw input. For example, in image processing, lower layers may identify edges while higher layers may identify concepts relevant to a human, such as digits or letters or faces. Deep learning has profoundly improved the performance of programs in many important subfields of artificial intelligence, including computer vision, speech recognition, natural language processing, image classification, and others. The reason that deep learning performs so well in many applications is not known as of 2023. The sudden success of deep learning from 2012 to 2015 did not occur because of some new discovery or theoretical breakthrough. Deep neural networks and back propagation have been described by many people as far back as the 1950s, but because of two factors: the incredible increase in computing power, including the 100-fold increase in speed by switching to GPUs, and the availability of vast amounts of training data, especially the giant curated data sets used for benchmark testing, such as ImageNet. And then we've got GPT. So we've got generative pre-trained transformers. So Chat GPT, there we go. So we understand what that means. So if you're going to take anything away from this video, at least you know exactly what that means. It means generative pre-trained transformers, and they're large language models that are based on semantic relationships between words and sentences, natural language processing. Text-based text-based GPT models are pre-trained on a large corpus of text, which can be from the internet. Pre-trained training consists in predicting the next token, a token usually being a word, subword, or punctuation. Throughout this pre-training, GPT models accumulate knowledge about the world and then generate human-like text by repeatedly predicting the next token. Typically, a subsequent training phase makes the model more truthful, useful, and harmless, usually with a technique called reinforcement learning from human feedback, or RLHF. Current GPT models are still prone to generating falsehoods called hallucinations, although this can be reduced with reinforcement learning from human feedback and quality data. They are used in chatbots, which allow you to ask a question or request a task in simple text. Current models and services include Gemini, which formerly was called Bard, ChatGPT, Grok, Claude, Copilot, Llama. Multimodal GPT models can process different types of data or modalities such as images, videos, sound, and text. And then we've also got specialized hardware and software. In the late 2010s, graphic processing units, or GPUs, that were increasingly designed with specific AI enhancements, use specialized TensorFlow software, had previously used central processing units as the domains and the mean for large-scale commercial and academic machine learning models for training. Historically, specialized languages such as Lisp, Prolog, Python, and others have been used. Okay, so thank you so much for tuning in for the second video of this AI stream. I'm going to now dive into more academic articles. I hope you indeed enjoy the content. Like, share, or subscribe to the content for future videos like this. Take care. Bye.